So we're going to start a new thing. We're going to start a podcast. And I invited Etienne Bernard. And Etienne Bernard is the CEO of NuMind. Welcome, Etienne.
Thank you for inviting me, Daniel.
With pleasure. So, Etienne, what's going on these days at NuMind?
Yeah, okay. So where to start? Maybe I should define a bit what NuMind is,
Sure.
right? So it's a startup that I co-founded with my CTO, and a year and a half ago,
Yeah.
we started that. We actually founded it 1 year ago, and we went to Y Combinator, and now we made a product that we are in private beta right now.
Mm-hmm.
And basically, this product is a tool to create custom NLP models.
Mm-hmm.
And so which mean, so NLP, natural language processing, right? And we specialize in the text understanding kind of models. So things to, classify documents, to extract information from documents. So classification and anti-detection are the classic task, are the main task actually. And it's to create models specific to a business application. That's what we do.
That makes sense. And why did you choose this specific application, this specific business model?
So this related to what I was doing before.
Mm-hmm.
I was working at Wolfram Research. I was head of machine learning there. I joined in 2012 and spent almost 10 years
Nice.
there. And basically, we're making machine learning tools, so a bit like what I'm doing now. It's a machine learning tool, what we do at NuMind. Also machine learning applications.
Mm-hmm.
And it was both for the Wolfram language, for Mathematica, and for Wolfram Alpha. And there was a lot of natural language processing application. As you can imagine, with Wolfram Alpha, you need to understand text and, Mathematica as well. And I was a bit frustrated and by how we were doing it, by the time we spent on labeling. We had a labeling team, think forever. And then we saw this large language model appearing. GPT-2, I think, was a big revelation. So they were understanding text, and I thought, like, okay, we have things that kind of understand text now. We should not spend this amount of time labeling, and it kind of called for a different tool as well. So that's where the idea started, and I would have started the company earlier, but then I decided I had the brilliant idea of writing a book, which was extremely time consuming.
I can imagine.
So
great book, by the way.
Thanks. And so after the book was over, we started that with Samuel.
So you're riding the wave of, let's say, revolution of machine learning. What do you think about the current revolution that is happening these days in artificial intelligence?
I think it's super exciting. I think very few people predicted that just by scaling up what we already kind of knew how to do, the last 5 years, let's say, it would lead to such results. I think many people were expecting there's going to be a plateau at some point. It's going to plateau. Yeah. It cannot just from passively learning from the web. It cannot really construct word models. It cannot really do any kind of reasoning, and it's doomed to fail. And actually, that's so funny. The first that impressed me was actually not GPT-2. It was further away. It was a paper from Google. I forgot when it was, the date, but it was 3 years before. And they trained on movie subtitles. And which means it was already a chatbot, because subtitles are a series of it's a series of different people talking to each other. So it's kind of an answer to a question, sort of. And so they made a chatbot, and it was LSTM, so it was not Transformer at the time. But they scaled it up. I think it was already a billion parameter on this order. Mm-hmm. And the thing was super good. It already learned, things about the world. Like, you could ask, what is the color of the sky? You would say it's blue. What is the color of a black eye? No, it was like, what is the color of blood? And it answered the same as a black eye, which I thought was amazing, because, like, okay, it didn't manage to answer, but it's actually It's actually a correct answer in a way because you see blood on the black eyes. And and I thought I was super impressed by that. Super impressed.
Mm.
And at the time, I mean, I thought this is my scale, but the authors themselves, they write, of course, this cannot scale further. Of course, you need to have goal-driven AI. Of course, it's super limited. It's autoregressive. It cannot really be a super AI. And it turned out they might be right in the future, but at least for the medium term, they were wrong. Just scaling this naive thing of predicting the next token led to things that are super impressive. I mean, they have limits, of course, but honestly, they're super impressive. I'm still impressed.
Yeah.
Now I'm still using them. I'm still impressed.
Yeah, me too. I've been working in the field for a long time, but when it comes to large language models, it was mostly through papers and me trying to apply small large language models into some software applications. But honestly, when I was able to experience ChatGPT for the first time, I did not realize how far along we were. I did not realize that we were so advanced already in being able to create something that is close to being an artificial intelligence. That was a
Same for me, actually. Same for me. I mean, I kind of knew GPT-3 was very good, you know, playing with it. But still, it was a bit of a shock. And I mean, I guess that's what happened. I mean, it's 5 years ago. Like the best models were kind of like, you know, BERT, GPT-2, these sort of things, 1 GB at most.
yeah,
Now it's 1,000 times bigger.
yeah,
And it's hard to comprehend what 1,000 times bigger can lead to some sort of emergent abilities. Anyway, and I think it will lead to so many applications, of course. I'm super excited. I don't think it's
yeah,
hype. I mean, there's a hype, of course. There's a huge amount of
yeah,
hype, but I don't think it's just hype, rather. I think, you know, of course, the chatbot, the assistant, you know, I mean, we communicate through language. So now that we have something that can, now, of course, the next frontier, like, yeah, the text understanding kind and the talking back to you and, you know, having an assistant to do basic things, I think it's kind of solved. I mean, at least on a conceptual point of view. Theoretical point of view. Now, of course, to make it in the phone and so on, it's going to take longer. But it's true. The next frontier to have a kind of independent agent that can really do their own thing, like run a company and so on. Like we're still far away. But what's interesting is that they kind of can do it a little bit of reasoning, a little bit of planning.
yeah,
That is, and through writing. That's a funny thing, is that they have no, you know, a funny thing you can do, right, with ChatGPT is like, you know, think of a number random between 1 and 10, you know, and it just cannot think of this number between 1 and 10 and keep in memory. It doesn't have an external memory. But the way it replaces external memory by writing stuff. And that's why I think good prompts are prompts that are like, before giving your answer, just write a lot about the context, all the thoughts you have, you know, reformulate the problem to yourself and so on, because it's actually his way of deducing things and kind of reasoning in a way through the text it writes, which is a hack. It's a hack. It's a complete hack. Like, I don't think that's how we do. We form kind of brain thoughts, and then we, you know, that we keep in memory, like a bit like LSTM sort of, and it's a hack, but it kind of works a little bit. So that's amazing.
yeah. That makes sense. That makes sense. You know, I was thinking last time. So we both are former physicists, and there is a very foundational moment of physics which happened at the beginning of the last century, between 1905 with the 4 articles of Einstein and maybe 1930. It's when the emergence of quantum mechanics happened. And it was a very, fundamental time where very new type of physics were really created,
Mm-mm.
and every new discovery was huge. Now, if you think about physics, if you find a new discovery, it's very small. It's very, um, it's in the details of a specific field. But at the time, it was very fundamental. And I feel that right now in artificial intelligence, we are living a very similar time where the things we discover are big. And I think it's going to continue for a little while. And we're going to be astonished, you know, day after day on the different discoveries we may make in machine learning or artificial intelligence. That's very exciting time.
No, definitely, definitely. Although to complement to that, uh, many discoveries were kind of made a bit earlier, right? Like Transformers 2018,
No, 17.
17, yeah. And so now it's also a lot about scaling up engineering, um, making this massive models fast.
Yeah.
That's but but always ingredients were kind of there. But yeah, I mean the last 10 years I think have been transformational.
Yeah.
And now there's so
The
many money and so many eyes and so on. And
money
of,
money is going to help.
I mean, of course, there's always Jan Leca is a big proponent of, I mean, how do you say that? Like skeptical about the abilities of autoregressive large language model to continue improve so much. And he says it might actually slow us down because now we have this thing that, this way of doing AI, so to speak, that is already been pushed. And so everybody wants to do the same thing, but I'm not thinking, how could we do different to go to the next step, next level? Which you might be right about, actually. There's
I don't know.
Still, I think, so much energy and money into it that this new way of doing AI, I think will emerge more rapidly now. I would say that.
Yeah. And what do you think about the impact of this new those new AI capabilities on our societies? I mean, there's a lot of fear about potentially people losing jobs. What do you think about that?
So the losing job thing is tricky. And, you have to understand a bit of, I don't know, economics and like, I mean, if we look in the past, all revolution led to a transformation of jobs, but never a net loss. Never happened.
Yeah.
Industrial revolution, and even some people were saying compilers are going to put programmers out of job because now you can do something in C instead of in assembly.
Yeah.
What's missing is that there's actually so much value to writing programs, so much that you can improve the productivity of programmers, by 10 times, 100 times. You just have 100 times more output, but it's still going to be useful output. So society will still want it. So that's the thing that is missing. But it's true. Some people say this one is different because this one is kind of replacing imitating our brain, so to speak. So this particular will be different from all the revolution that happened before. I think that we might be underestimating all the things there are to do. Sometimes we are limited by our imagination. If we have, let's say, infinite, a lot of energy and a lot of intelligence, which this thing brings us, like we could do amazing things. I could do, a spaceship to go visit the galaxy. I know, but I mean, it's like there's a lot of things we can do.
Yeah.
And if that's the case, then it's just imagination kind of the limit. But then I think people will have job in the sense that they will be able to do useful things. So I tend to think that now, of course, some job will be removed. I ran recently in France at some company that were doing press review. Something that Google News does already pretty well for a while. But I guess it was specialized for topics, press review that we're selling to companies. And now you can have a computer because you have super good text understanding, so you could automatize that. So yeah, this thing gonna go away mostly, and a few
Yeah,
other things.
does that make sense? You know,
Oh,
the way I see it,
sorry.
do you finish?
No, yeah, there was one thing. There's one thing.
Yeah.
There's actually one kind of job that will not go away for sure as well, which I think is
Mm-hmm.
pretty obvious, is a job for which we want a human to do it. And it's that is specific, like even if you have something imitating a human, the fact that we know it's not a human, we won't like it. You know, like let's say a singer going to a concert, you know, like you enjoy that it's somebody like you, that you know they had histories, you know, they grew up as a human. If you see a
Couldn't you
fake singer, you'll be like, eh.
couldn't you argue that when you watch CGI movies, or you know, like 3D animation movies, or even if you watch a movie and you have some CGI, wouldn't you argue
That's true.
that we have something there
Yeah.
that
Yeah, for actors, I think we don't care as much. Uh, for listening to music in your car, also you don't care that much. Going to a live concert, I don't know. I think we care.
what about
Um,
DJs? You know, we go to DJ concerts. It's it's not fake, but it's a very different way to put music together.
it's DJ, I guess, is a bit in the middle, I
Yeah.
would say. But otherwise, you have jobs like, you know, taking care of other people.
Mm.
You know, there's things that we will be okay if it's an AI, but for example, like, I don't know, you're in a nursing home, you're an old person. Would you be okay to have only robots taking care of you and that you know that they are robots?
I guess it depends. Robots don't have empathy, but if it's just about serving meals and providing medications, those type of manual labor could could potentially be replaced without too much
I think
feelings about it. I don't know.
no, I agree with you a fraction, but I would like to still have somebody that just I know had the same kind of experience as me growing up and everything. Like a friend, you know, like having an AI friend, all right, but not only AI friend. Like I want to have somebody that I could relate fully, you know?
Yeah, I think we all have these feelings, but when will come the time to have actually those type of replacements, and those replacements will be able to do, you know, jobs efficiently for cheaper. I think those feelings are going to go away very quickly.
How many, yeah. There will still be things to do. Yeah, and yeah.
Honestly, I'm looking forward to the time AI will be able to replace us completely, such that we can spend the day on the beach tanning.
Be careful what you wish for.
No, but it's difficult to know if AI are going to, you know, have a net loss when it comes to the jobs it's going to displace. But I think historically what we've seen is that every time we have some type of new tool, new automation, new abstraction for people to be able to um, perform their job better,
Mm.
it did not impact the economy. It actually helped it
Oh, for
because,
sure.
yeah, some jobs will be displaced. That's I think there's no debate on that. But the productivity is going to increase, and it's going to open new markets, and it's going to enrich current markets. So when you think about cloud services, it's always an example. You were using the example of compilers earlier, but I like the idea of cloud services. You know, like before in the 90s, if you wanted to stand up a website that could scale to millions or billions of people, you would need a team of 100 people. But these days, with cloud service like AWS, you can actually do that with one person. Uh, and it doesn't mean that you actually killed 99 jobs. You were able to, because now you can do that more easily, those 99 other people can focus on
Yep.
task, think about more complex applications instead of some manual labor that robots can do.
Yeah, I 100% agree. And yeah, I think that's what's going to happen. And of course, there's, you know, some people have other fears rather than just job displacement.
Yeah.
And yeah, so I don't know, maybe that's something we could talk a bit about as well. I guess one of them is just, if you empower everybody with a lot of intelligence, then everybody can do a lot of things, including harmful things.
Yeah.
There's a classic ChatGPT, please help me build a bomb, which is actually is forbidden by ChatGPT.
Yeah.
So that's one fear. And it's true that, I don't know, let's say you have a biological lab in the cloud and it's a lot of intelligence and you can synthesize a virus from, in your room. Yeah, that's some things that people, I don't know. So I'm curious, what are your thoughts about these things?
Like ChatGPT providing ease to be more harmful. That's
Yes, exactly.
well,
And will it be a problem?
I think it will always be a problem, and we'll need to make sure that we think about how to counter that. When we had some threats around cybersecurities, it was something new at the time because we provided tools to hackers to harm other people, and the legal authorities were not ready to fight this kind of problems because there were no laws and there were no antecedent in with this type of problems. But I think it's a matter of making sure that uh, the legal authorities, government, works with um, those creators of potentially harmful tools, like AI could be, to design the right regulations such that we protect people as much as we can.
Yeah, no, that makes sense. I guess one fear that people have is that it's going to move too fast, and so we won't be able to put the appropriate defense. And this I disagree with. I think
It's moving fast.
I
It's
think
moving
it's
fast.
moving fast, but I mean, there's a bit of an illusion the last year, since basically ChatGPT December last year,
Yeah.
because actually GPT 3.5 was older than that. But they made it a chat version, which suddenly made everybody realize its power. But if you look, GPT-2, GPT-3, and like GPT-4, it's actually quite some time beneath, and GPT-1 as well. So I don't know how much it was, but typically 3 years. Every 3 years, there was a new version.
So I think something that is somewhat different in terms of the acceleration that may be perceived is that we always had some improvement developments on some algorithms and techniques in machine learning, and we could easily outline dates on very impactful uh, development of that field. But I think there's something a bit different that is happening right now in a sense that like every 2 days, there's a new tool, a new development, a new paper, a new software application that comes out and that can directly be experienced by the common people. Like this morning, I was looking at a new uh, development by the Google research team on how to interact with images and to make it like an interactive video just by having that still image. And there was a time where you were surprised every 3 years about a new development. But I feel that these days I'm surprised every 3 days on the new developments. So there's something different happening, I feel.
That's true. I mean, I guess, yeah, these new text and image models, they were kind of raw. Like the intelligence was there, but they were not really useful. And suddenly everybody managed to make them a little bit smarter, but also quite more use. And then now it's kind of a gold rush to apply these things to a bunch of things. So it's true. Now on the sort of harmful things, I haven't seen a lot of, I mean, if I look kind of the benefit versus harm,
Mm-hmm.
I feel that for now the balance is heavily on the benefit, heavily on the benefit. I haven't seen example of things that
Well,
at scale. Uh,
there are examples of teams being laid off to be replaced
yeah,
by
but it's
what AI could do.
yeah, but I mean, I think it's minor in the
In
everything
the grand
that
scheme,
this yeah exactly and what this the benefits of AI is, which are going to be we talk about the long term about AI doing a bunch of things for us, but even on the middle term, for education, that's
yeah.
something having some personal teacher that can answer all your questions, that is super knowledgeable and reasonably smart. I think this is going to boost and I mean, of course, there's also health and there's a bunch of other applications where it's going to be so much benefit, so much. So for now, I'm really not in the camp of slowing down, really not,
Yeah.
because I see the direction we are going, which is huge amount of benefits and potentially some harmful things. I think we should actually accelerate as much as we can, and then of course, as soon as we see problems, as you said, we have to put safeguards, legal safeguards, and find way of countering this all the time
I guess
and make it
I
safe.
guess we'll need yeah. I guess we need to rethink a bit the way we perceive some things in our societies. You were talking about education, for example. There's a lot of cases where students were using ChatGPT to cheat on some tests or some homeworks, right? Um, so my feeling about that is that well, maybe we should rethink the way we test people. We should rethink about the way we learn. Do we need assessments that robots can do to test our knowledge on some subjects, or is there another more efficient way to learn to be useful with what we learned? So it's a question, I guess, of rethinking some aspects of our societies and to see how AI can fit into it to help us and not to be harmful.
No,
It's not,
definitely.
yeah. So we were talking about prompt engineering or prompt, like designing prompts earlier. Uh, it's a big debate those days. This subject, like the idea that we have something called prompt engineering. There's a big hype around that idea. A lot of people are debating the idea that it's a engineering domain or not. Um, and I guess there's a lot of influencers that non-technical influencers that are able now to uh, call themselves uh, prompt experts or prompt engineering experts. Uh, what do you think about this hype around prompt engineering
Yeah.
and how does that fit into
I
this?
mean, yeah, I think, okay, a few things. First, I completely understand the hype. That's really a new way to make the computer do something by just writing text. Like we're programming with natural language,
Hmm.
which is amazing, but it doesn't mean that it's easy by any means, because I mean, we know that for humans, you cannot send an email to somebody. Let's say, you're managing a team. Let's say you send an email to do something. You cannot expect the thing to be done the way you said, because there's a lot of
Hmm.
things, you have a lot of different interpretation of your email.
Yeah.
So we're actually doing prompt engineering in a say all the time when we're talking to people to make ourselves understood.
Hmm.
And actually, I've heard people saying that in education, one thing we should teach people is how to just be clear and defining well what they want, because in the future, like I mean, already with humans it's important, but now even with computer it's going to be important.
But
So yeah, yeah.
prompt engineering goes beyond that, no?
Well, it's kind of modifying your prompts
Mm.
to make the thing do what you want, which is kind of a reformulating this email that you send to someone until this person understands. So it's a real thing. And actually, we are doing some prompt engineering in NuMind for various applications. But it's also a bit transition, or do you say, it won't last long. transition time. I can't
Oh,
find the word.
it's a hype, right? It's going to,
Well, yeah. Or hype, I don't know, because it's real. It's real. It's a new way of making a
it's,
computer. But
but
it's
it's
not
going
going
to
to last
fade.
forever.
It's going
It's
to
going
fade.
to transform. Like the prompt engineering that we do now will have nothing with what we do in the future. And the key is interactivity.
Mm.
So right now, even though ChatGPT is a chat, so it seems interactive, it's actually super passive. In a sense that it's a sort of instruction, answer, instruction, answer, instruction, answer.
Yeah.
But it would never tell you something like, oh, I don't understand that. Why do you want me to do that? Or doing suggestions, or doing and that's what, by the way, that's one of our core philosophy at NuMind.
Mm-hmm.
Something that we called interactive AI development, and our thought about that, our idea, or how it originated, is what is the most efficient way to define a task? What is the most efficient way to define, what a computer should do? And I thought a very efficient way in terms of information bandwidth is to teach a bit like we teach each other, humans.
Mm-hmm.
And the way that works, and I always take the example because it's related to what we do at NuMind. Like, you hire someone to classify your emails. Okay. The first thing you're going to do is describe the task. Hey, I want to classify this email. That's a type of class that I'm looking for. And you might also say why. And you might also give a few examples, good examples, like the same you put in the documentation, the one that are helpful to understand. And then a conversation will start. An interaction will start. So the person will start labeling the emails, and they will go back to you and say, hey, I don't know how to label that email. I just don't know. So please help me out. And they will ask, why? Which is, by the way, super information rich.
Mm-hmm.
Like, if you were, let's say I was recruiting at some point, and I was thinking, oh, maybe I should do a classifier for the resume, good resume, bad resume. If you just say good, bad, bad, good, bad, good, bad, you're going to have to label thousands. And it's not because the machine is stupid, even if the machine is super smart,
Mm-hmm.
because the information you give is actually not so high, not so rich. Sometimes you remove a candidate for some reason, just because it's in a different country, just because everything else was stellar.
Yeah.
But if you say why, oh no, not this one, it's from bad country. Oh, not this one, they failed at this question. Oh, not this one, I think they're too qualified. Oh, not that. Then it's going to learn super quickly. So the why is missing. Then you can also have suggestion from the person you're training, which can be a machine or a human. Say, oh, actually, we want to classify. Maybe we should classify this way, or create this new label. And that's all that we call interactive AI development, which is, in my way, the optimal way of defining tasks until we have direct brain interface. Then we can share thoughts extremely well, which is also useful for yourself to define the task. Sometimes you're actually not exactly sure about the task. And it's this interaction that makes you define it. And this, I think, is missing in the current, ChatGPT-like LLM. And that's why we need to do prompt engineering. But when this will be generalized, then it's going to be a much nicer prompt engineering. It's going to be like, do that. And they're like, okay, did you mean, they will ask a bunch of questions. It's like, oh, what do you mean that? Oh, why? Oh, I don't understand that. Okay, can you precise? And then little by little, you agree. And at the end, it will be clear. You'll be, okay, I think you understood. You won't even need some sort of testing. The thing will know. It'll say, I get it.
That makes sense. But let me press on the concept of engineering. Like, I think what you're describing is very much very basic communication capabilities, things that we learn in elementary school, right? And I agree. I mean, at some point, that's the level that we should try to reach. This simple interaction with an AI that does not require any too much care in the way we formulate our request. But there's a whole field of how to design prompts. The simple fact that we call it prompt engineering seems to imply that there's a skill to it that you need to learn and train for. And so there's a certain expertise that needs to be developed to actually interact with LLM. What do you think of? Do you think that there's a real need to develop an expertise? And if we need to, is that expertise uh, deserving the label of engineering?
I think there's a need at the moment.
Yeah,
I guess it will stay there in some form, but it's going to be greatly reduced in the same way as we still need people to do, low-level programming and assembly programming.
yeah,
But most people do high-level programming or even like use no-code solution. So I think that's what's going to happen. There's still going to be people do the prompt engineering in a sense, but it's going to be minor compared to everyone that are using and do amazing things with this LLM in a very natural, interactive way. And they won't need a special training for that. I mean, yeah, which is communication, understanding what the computer tell you back and be able to answer to that, which what we're training as humans a lot. And yeah, I think that's something that you say we learn in elementary school. That's true, but we continue learning it after.
yeah,
And
for sure.
and so yeah, being good communicant, it's going to be an important thing, which requires also understanding. So it's not like we cannot just delegate everything to the machine. Like we have to be part of it if we want them to do what we want them to do.
Yeah, for sure. I think I have a similar opinion than you in the sense that I think right now I work, I work with LLMs very often, and 90% of my time is spent designing the right prompt for the LLM to do exactly what I want it to do. So there's a lot of time spent trying to fine-tune the prompt, and in a sense, it's very much, spending time engineering a prompt. So there's a lot of that when you work with LLM these days. And I think with LLM improving, with LLM having better ways to be fine-tuned to what humans are expecting, I'm expecting this type of prompt engineering to fade away, or at least to be simplified or abstracted in some simple manner, such that common people can really interact with LLMs and really get what they exactly want. But I think there's another side of prompt engineering that is not going to disappear anytime soon, and I think is going to actually become richer and richer, which is a type of prompt engineering where that we designed to build software applications with LLMs. So I'm thinking about like prompting strategies like React or chain of thoughts, tree of thoughts, prompt, plan and execute, that are really meant to build applications or to use tools, augment LLMs.
Yeah. So this is linked, and go back to our conversation earlier, to the autoregressive nature of these systems.
Mm-hmm.
Because they have autoregressive, they don't really, they don't really have memory. They don't. So in order to do reasoning, in order to do plan and so on, they need to write it down.
Yeah.
It's a bit, in a sense, it's a bit like this movie, this Memento movie.
Uh-huh.
Where, I forgot exactly, but I think the guy loses memory every day or something like that.
Yeah,
so he has to write everything. And that's a little bit what it is with this large language model. They have to write. So the fact that they have to use that in order to reason, which by the way is funny because language is symbolic.
Mm-hmm.
So, okay, if we go on a complete tangent, AI used to be, and people believe that AI had to be symbolic, do logic and reasoning on discrete type thing, because that's the way we speak and also the way we program. And so it made sense that AI, and the big change was Well, actually, to resolve tasks like image, understanding an image, understanding text, and so on, this logic, this symbolic logic is not great. What works much better is to use sort of intuition. Like it's kind of you have sort of reasoning, like logical reasoning, and you have intuition. And intuition is much better, and you have this neural network that process data and in a more fuzzy way. And now, in order to perform complex reasoning, it has to write down with symbols. So we did a loop, and it's actually using, in a sense, a form of symbolic AI to do its thing. And because of this, I think prompt engineering is kind of important, because we're still hacking these systems. We're still like, hey, you have to write a lot of things. You have to think step by step. You have to do this. But when they get better, when they are not autoregressive anymore, I think this will clearly fade away.
I don't know if I agree with that. Let me try to think it through. So an AI, or the generative AIs, the LLMs we are thinking about right now, we basically use data that has been generated by intelligent agents like us, humans, and we train. We basically build a very complex architecture that has the flexibility to learn the statistics, to extract the patterns, statistical patterns of that data, to try to mimic the intelligent agents that generated that data in the first place. And that's where machine learning departed from symbolic AI, in a sense that instead of trying to encode intelligence into some formal algebra almost, we step back and we try to actually say we cannot encode and we cannot formalize intelligence. We're just going to try to mimic it by extracting the statistical patterns from the data. And to me, prompt engineering is not as much. I mean, I understand what you're trying to say with symbolic, but to me, it's closer to a programming language where LLM is a very flexible function, a subroutine, and a prompt is a codification of the instructions we want to provide to that function. And in a sense, I would not describe it as being AI. I would describe it as being closer to programmation.
I agree. No, I agree. It is programming. It's just that the way we're going to do programming, I think, will evolve. And so actually, I think the analogy of assembly is pretty relevant here. There will still people that will do the low-level work of programming the LLM directly, but the vast majority will use more advanced. And when I say LLM, it doesn't have to be an autoregressive LLM, but AI system. But the majority it will be full conversation.
I had this question, like you said, somewhat that a problem with LLM is that it's autoregressive. Can you clarify what you mean by that?
Yeah. So what the autoregressive LLM does is just predicting the next word.
Yeah.
Or the next token, and then it re-injects this token inside, and then it computes what should be the next token. But let's say, for example, ask you to write a book.
Mm-hmm.
That's not how you would do it. You would first think of a theme for the book, a topic. You might think a little bit about the characters. You might have some sort of story, which might be fuzzy. Like it's not necessarily, it's in your brain. It's some ideas, some feelings, and so it's more of a top-down approach.
Yeah.
And we kind of plan as well. And then you would start writing, which might not be from the beginning, actually, it might be from wherever. And then you might also modify it. You might also iterate over it. that's very different what's happening with LLM. First, there's not this top-down approach, because what matters is where the random numbers are generated. In an LLM, you put the sentence, you put your prompt. It computes, it's all deterministic. There's no random number at all.
Mm-hmm.
The only thing it does is computing the distribution for the next token, and then it's through a random number. And in a sense, a random number is taking a decision.
Yeah.
So the only decision it takes, so sure, it computes, it has some sort of fuzzy memory before, but decision is made for the word. And so it's really weird, like write a book and, make, before thinking about everything that's going to happen after, you have to make decision for the first thing. So actually it tries to think about what it's going to do after, but it's very difficult. It's actually, yeah, I would like maybe to write a blog post about something, because it reminds me of what I was doing in physics. So basically I was doing Monte Carlo, Markov chain Monte Carlo simulation to study the simplest kind of liquid, which is just art spheres. They just cannot overlap, but they have no attraction, and it was in 2D, so it was actually art disks. And we're studying phase transition and such, but the way you generate a random, so that was the goal. The goal was to generate random configuration of art disks.
Mm-hmm.
And you might say, well, I start putting one disk, and then I put another one, and then I put another one, and then I put another one. This doesn't work. This is super inefficient. Mm-hmm. Because in order to know the distribution for the first disk, or maybe the second, if you have periodic boundary condition, doesn't matter, but you have to anticipate what are you going to do with all the other disks. And it's super hard to compute. And so a better way is to start with a configuration and then modify it little by little, like it's more goal driven, and you modify until you arrive to the solution. That's what you would do for your book, by the way. You would have, so first a top-down approach. So actually it's two different things. It's first a top-down approach. You might think more generally about how the disk should be and so on. And then modification to obtain the solution. That's why I must say I was wrong, but I thought the autoregraph models were doomed, would not work. For this simple thing. Was like, how on earth can you not take any decision, and you have to anticipate everything that's going to happen after, and you're going to get the right word? I was thinking, that's so crazy. That's not the right way to do. And obviously I was wrong, because it works super well, but it might still be as a limitation. And that's what I think somehow when Yann Lequin says, when you think about it, it's a bit crazy.
Yeah, I agree with that. It's one of the reasons I was completely surprised by the capabilities of tool like ChatGPT to be able to reason. That's not something I expected. So, a model that can predict some numbers, a model that can try to guess the next word by sourcing in what it has seen before in its training data and trying to pull out the word that seems to make the most sense based on what he has read in his training data. Okay. But to be able to establish a whole reasoning based on just predicting the next one, that's pretty surprising.
Yeah. I mean, it's mathematically correct, in the sense that if you imitate to predict the network well, then you can generate, anything like scientific paper and so on. So you kind of need to be smart. But in practice, I would have said that's not the right approach. And like many other did, like this paper on subtitle or Google, they said the same thing. It's called a neural conversational model, by the way, I just remember. You might think you need to have a more top-down, goal-driven approach, and where you iterate over your solution as well. And so top-down is like some form of planning. So some form of planning and some form of iteration, and which, by the way, is what happens for images. When we generate an image, like all this diffusion system, it's not autoregressive. They don't generate a pixel, then the next one, then the next one. There were autoregressive ones. They're working pretty well. But the one that ended up working better is the one that kind of starts with an image and modify it. And so it's a bit goal-driven and iterative approach. And you also have random numbers at the beginning. So in a sense, the decisions are made before. I guess you have random number all the way. Like the GANs were only at the beginning. Like you put random numbers, that's a decision you're going to make, and then it process, and you have an image. And the diffusion, I guess, also have random numbers in between. But that makes more sense. So I would bet, I mean, it's pretty clear that it's going to happen for text as well. I think that would be crazy if it does not.
To what?
To be not autoregressive, not just autoregressive. It seems like it's much more efficient to make decisions about the entire thing, by throwing random numbers before, and also to iterate over, I guess, what the thing answers and does.
It's a good point.
Yeah.
When I think about how we solve that problem right now, we actually use frameworks that are where we establish a thinking framework for the LLM to fit, to follow, such that you can have it plan and you can have it try to make some decisions over the course of multiple iterations. So basically, we are solving this problem with some deterministic software. So I'm thinking about LangChain, for example, where you can encode the way to structure the thoughts for LLM to follow and provide some structure around its way it's reasoning. But because I'm biased with that type of way to structure thinking, I wonder if we can actually inject all of that into the AI itself and have the AI being able to have that plan, that reasoning, beyond just being able to just predict the next word.
No, I think it's going to happen. And in the same way, yeah, and now beyond not planning and beyond not iterating, the other issue is that it uses symbolic words to do the reasoning. And often, I mean, symbolic are really good for some things, but often a more numeric way of encoding and processing information is more efficient. I mean, that's so I think, and I think we do both actually. When we think, there's a part that is indeed symbolic and a part that is numeric.
Yeah.
And it's kind of missing that. It's going to happen. I mean, I don't know when. Problem is like timelines. I don't know. People will push the NLM. So that's a bit of an issue, right? If it's works so well, then people that worked on alternative, everybody laughs at them. Look what the other do. Yeah, but in the future, it's going to be.
We have there's an app. I mean, there are approaches beyond just being too aggressive, right? I mean, a model to generate text is always autoregressive. But when it comes to being able to educate it, we have techniques like reinforcement learning to help it to understand a bit better how humans tend to think. So just beyond extracting statistical patterns from the underlying data, we're able also to give it a sense of how to have a more human way to think. Do you think that this is going to be, like, if we push in that direction, do you think it's going to be potentially the right way we may solve for that?
Yeah, you're completely right. It's a fix. So another way to see the issue of autoregressive model beyond, it seems crazy that you don't plan everything to happen. It's super hard and so on. We're just sort of thinking from where I come from physics, but one, and actually I think that's how Yann LeCun explains it, is that if it does a mistake, sort of, then it re-injects the mistake in the system. So then it has more chance of generating a mistake after,
Sure.
Of course, it's not like there's a perfect solution or not perfect solution, but you get the idea. And so it's unstable, like it's an unstable thing, because it re-injects its thing. So it has to divert at some point.
So
And
it's what we call and it's as hallucinating. It's what we call hallucinating, no?
hallucinating, I guess it's part of hallucinating, but I guess hallucinating is also just. But yeah. It's related. Yeah. It's and it can become completely crazy. And I think GPT-4 through beings are allowed to interact a long time with it, and that's why people were managing to make it go in crazy direction and become completely nuts. And most likely what's happening is that you talk too long and there have been too many mistakes in a way, and there's a way to see it in a machine learning perspective is that when you train, okay, let's go to classic machine learning, like classifiers. You train classifier on the training data, right? And then you put it into production. I mean, you test it, whatever, you validate, and then you put it into production. And the hypothesis we usually do is that the data is in production is from the same distribution as the data during the training.
Yeah.
They're in the same domain, we say in distribution or in domain is probably better. But of course we know that it's a little bit different in production, so we need to correct a little bit, but it can be the same domain. It can be the same distribution, with NLM, what's so interesting is that it generates data and then it learns from the web, let's say, to imitate the web. But then you re-inject the data that it generates to itself. So we actually know for a fact that the data it ingests is not from the same distribution as the training data, because it didn't learn the distribution perfectly. We know there's it's not a perfect, it didn't learn perfectly the web. There's always some mistakes. So it's kind of a guarantee. It's like a machine learning system that is guaranteed to work out of distribution, out of domain. And when you think about that, in a way, reinforcement learning with human feedback, I guess reinforcement learning is just a detail. Don't really care. It's more the human feedback, and it's more the fact that for the first time, the LLM is learning from data that it generated itself.
Yeah.
You see what I mean?
I wonder about that because when we talk about in and out distribution, okay, so we train LLM with web data, and it does not generate web data. It generates something else, and then it's utilizing that something else. But I would argue that the way to categorize or to qualify the data that we use to train that type of model is not really about being web data. It's not really about the subject that the data is treating, but more about the way the different tokens are being linked to each other in a sentence. So I would actually say that the type of distribution we ingest at training time to an LLM is not about a distribution we qualify to be web data, but it's a distribution we qualify to be how humans logically connect tokens to each other in a sentence. And as such, I don't think it's generating out of distribution. It's not generating data that has been seen on the training data, but it's generating tokens, because it's autoregressive. It's generating tokens that are capturing the logics in the way we communicate and articulate thoughts in text.
Yeah, no, I see what you mean. This logic, in a sense, can be represented as a distribution. And so I guess it doesn't matter in a way which training data it is. The LM is trying to approximate the distribution it's given. But it's an approximation. It's not exactly the same. And it only learns in this first phase when you create this, base LLM before doing human feedback tuning,
Mm-hmm.
only learns from data that is external, like it learns passively,
Yeah,
and it tries to approximate the distribution that it sees.
sure.
But it's an approximation, so there's a difference. And then when it's running, if it's just going to generate one word, it's fine, because the prompt in a way might be from the same distribution as the external data, although maybe not, but whatever. But anyway, when you generate many words, because many tokens, so these tokens are from a distribution, the sequence of tokens are from a distribution. I mean, it doesn't mean anything. That have been generated from a distribution, which is a bit different from the distribution it learned from, because it's an approximation, but then they are re-injected. So by definition, like this is like mathematical.
Sorry, they are re-injected through the autoregressive
Exactly.
process.
Exactly.
But also, I mean, you could also argue that it's re-injected by generating new web data that could potentially be used to
Okay, there's
train.
other things. It's another thing. It's another thing. But here I'm just talking about when you use an LLM, you train it on to approximate the distribution of whatever data you give. It's an approximation. Then it generates from distribution that is a little bit different.
Mm-hmm.
And then because its data is re-injected in the LLM, it means that it's working on data generating from a distribution which is different from the training. So we know it's absolutely certain that they are working out of the main. You see what I mean? For the base LLM, not for the fine tune with feedback.
So can I interject? Because I don't know if I guess I don't know if I agree on the terms here. So let me try to break it. I mean to walk you through my thinking here. So let's come back to typical machine learning. Like you have some tabular data. You train a model on that tabular data, and in production, when you deploy that model, you hope that the production data is of the same distribution than the data that has been seen at training time.
Mm-hmm.
When we talk about distribution in that situation, we think about the distribution of samples that are provided to the model at training time and at inference time. But when we think about distribution, we assume that statistically speaking, we have enough samples to describe a distribution. That statistically we can describe a distribution, but potentially we could approximate by a probabilistic distribution. When we come back to the example you were describing, obviously we have a distribution of data at training time because we have a lot of data. So we can statistically define the distribution. But when you think about the autoregressive process, here we are talking about a very few amount of samples, right? We are saying one word, we predict a word, we inject it, right? It's a very so I feel it's unfair to describe this as being a different distribution because it's true that that's potentially something that has not been said. But in the training data, but I would, as an analogy to the traditional machine learning, I would say that it's more similar to receive a sample that has not been seen in training. And a sample does not describe a distribution. It's just a sample that has some values for the different features. And it's not because it has not been seen in training that it comes from a different distribution.
Well, no, I agree. One sample is a distribution, even if this sample has been generated from a different distribution. So this is kind of a not really a way around it, but I agree with your intuition. Is that when it's small, when it don't make the LLM generate a lot, it doesn't matter. And which also goes with the intuition of the sort of chaotic nature of this autoregression, like when they make a mistake. So there's probably like for chaotic system, at least for this base LLM, this is
Mm-hmm.
like a typical window length, number of tokens where they're typically fine. And if
Yeah.
you go behind, they get crazy. And so the human feedback, I think what's happening is that because we have them actually generate stuff, and having humans saying that's good, that's not good, for the first time, it's like, hey, that's the data that I produced, and so it's learning to kind of correct its mistakes.
Mm-hmm.
But it's true. It seems a little bit like a hack. I mean, not that much. It's a good hack. It's a good, and actually,
Yeah.
it made a lot of difference in the usability of the system as well. And but still, it's still autoregressive. That's a good question. Okay, that's a really really good question. So this argument that okay, the autoregressive, they eat their own food they are created, and so it's chaotic. But you could have good repairing mechanism.
Okay.
You could have things like actually, and we do that. Some people argue this, like we do that in speech. Like you start a sentence and then you stop, like, oh no, actually, no, that's not what I wanted to say, and you continue, and you can become very robust to that. And so actually, I don't know the answer, but I think the argument that it's chaotic by nature, it will always be chaotic. There is some truth in it, but in practice, it might not matter if it really learned to be very robust, to self-repair. It does some mistakes, but it's actually correct itself, and then it's very robust and it's fine, and it can just generate. So, but it still hints that it doesn't seem the best way to do things. It's like this autoaggressive seems a bit, not the best approach.
I mean, I
Even though it
agree with
works
that.
amazingly well
I agree
for
with
now.
that. It seems counterintuitive, but actually would work. Yeah. So I had a question. So you've been saying that you were a physicist. I was too. Actually, we studied together in France, and you went
Do
to
you
the.
remember? We went to a
I remember.
neuroscience like class together.
Oh yeah. Well, I took 2 lectures of it and I left.
Yeah, actually, I remember that as well.
That was. I'm not sure it was pretty good.
It
I
was
don't
a lot on
remember.
biology. It was a lot on the biology. But we already
Yeah.
had this, even though I don't think any of us knew what machine learning was at the
Yeah.
time. We
I
already
still
had
have
this
this.
attraction to intelligence.
I still have the textbooks of that class. There was a and I still haven't read it. So like a lot of so you went to do a PhD in physics. I did too, and I noticed that a lot of physicists or a lot of people that started to study physics ended up to be working on machine learning.
Oh yeah.
Do you notice that? Do you agree
Oh
with
yeah,
me?
absolutely. I see that all the time. I mean, many of our common friends, and even the one that were the most into physics, at some point they end up data scientists somewhere.
Yeah.
Uh,
Why is
so,
that? Why is that?
well, I think, I mean, there's a modeling which is similar, making models in physics, models in machine learning. I think there's a lot of similarities. There might be, also people that like physics like this as well.
Okay.
Like, I think I think it's kind of feel that attract the same kind of people. And of course, I mean, there's an AI revolution, so this is super attractive to everyone. I don't know. For me, I don't see a big difference. I went
From
from
physics?
physics. I mean, I
Yeah.
went from physics to statistical physics to machine learning, but for me, it's continuity. It's a complete
Yeah.
continuity.
I feel the
I
same. Yeah.
don't feel that I changed both in a way.
I felt I did the same. I was doing the same job as a data scientist than I was doing that when I was doing my PhD.
Oh, yeah.
So yeah, very similar type of work.
I mean,
Very similar.
experiments. I mean, this is obvious. All the experiments you need to do.
I was a theorist. I was a theorist.
Oh, yeah.
So
But you need to also
I
to understand a bit the theory. I mean, it's like,
yeah, but we did. I mean, like you did, right? You did a lot of numerical simulations, which are experiments.
yeah.
But they are usually qualified as being theoretical research. Even then, it's very experimental.
Yeah.
Um,
I see that more as experimental.
yeah, I felt the math was very similar. The the tools, the mathematical tools,
Yeah. There's even
even
some words that are taken from it, partition
the words.
functions.
Yeah, it's true, it's true. The fact that in physics we are very comfortable with the idea to work with probabilistic system. It's something that we learn with quantum mechanics and with statistical physics.
Mm.
When we comes to when we come to work on data science problems, machine learning problems, we are comfortable uh, being able to think about an event being probabilistic. It's makes it very similar type of thinking.
Definitely.
So what led you to machine learning?
Aha. What led to machine learning? Okay. It's honestly, it encapsulates a lot of the thing I like. Like it's almost a perfect storm. Um, I liked computers from a young age. You know, uh, I was lucky at home.
I
Uh,
hated computers.
I hated I remember we're doing numerical physics together, and you didn't like it so much. I loved it.
Hated that.
Um, and like programming. I mean, when my father told me the first time, you know, so I was playing game on the computer, of course, and then so you know, in this game you can actually make them, you can program them. You know, that's just magic. I was like, what? You know, and of course, like many, there was a point of my life where you know I want to be a programmer to program games. You know, um, then there was physics, also driven by my father, uh, which was just you know about understanding the world. Like who doesn't want to understand the world? I feel we're all physicists, you know, babies
Hmm.
are physicists. They discover about, they do a bunch of experiments. They want to understand the world. So I think I kept my baby desire to understand the world. So I wanted to be a physicist. Yeah, that was a thing. That was a thing. And so that's why I went into physics. But I also like probabilities.
Yeah.
Uh, uh, from playing games, you know, board games. Like you play Monopoly, and
Oh
you have
yeah.
to know that when you throw two dice, it's more likely to do seven because there's more combination, you know, 1 and 6, 2 and 5, and so on. And I think that's why when I arrived, when we were together in bachelor and we discovered statistical physics, I felt completely in love with it. It was mixing, statistics, probabilities, and physics, and I thought it was so powerful.
Hmm.
I've been attracted to powerful things, like programming. No, but like you know things you can do a lot with.
Okay.
Uh, like computer, you can do a lot with. Statistical physics, you can do a lot with. Just with a few statistical arguments, you can understand how a big system behave.
Hmm.
And and then there was the last element, which was computers. So it was probability, physics, and then computers going back in the mix to do numerical simulation for statistical physics. So this I really loved it. It was almost the yeah, I thought as high as I could get into things that I like to do, even if the research process, you know, writing papers and so on might be a bit annoying. And then the last thing was to realize that, of course, AI is something, you know, it was something that actually we played to, you know, Otello Versi, this game, you know,
Yeah.
and with my father, so it was no machine learning at all, but we're developing some small AIs to play against each other. So it was really fun to have something that does it by itself. You know, it was all coded, of course. I'd put some rules, you know, and things like that. But it's so fun to do something. And so then when I realized 2010, it was a Netflix prize,
Oh yeah.
or maybe 2009, I don't know, during my PhD.
2009. Yeah.
Yeah. And I realized, wow, so you can analyze all this data and figure out what people predict, what people will like. This was a pivotal moment. I learned the word machine learning thanks to this. And then I realized, oh my goodness, there's computers, there's sort of physics, there are models, there's statistics, probabilities, and this will be able to create AIs. And I was like, oh my goodness, this is going to be my life. I'm 100% certain of it. So I left physics, joined Wolfram Research, went to do that. Nothing in terms of machine learning there, which was great because then I be able to, you know, doing things and then create the machine learning group there. And then I led the machine learning group and I don't think I will go out of machine learning or AI, for the next 30 years.
Well, it's a much more romantic approach to a career than mine, I had to say.
What is yours? What is yours?
Well, I mean, I do love. I mean, I like mathematical modeling, and I was doing a PhD doing a lot of mathematical modeling, and I wanted to do something that resembled something like that. After I was doing a lot of programming too, so I was comfortable with the idea to potentially become a software engineer. But it was much more grounded in the sense that I needed to find a job. Physics is not a job. I mean, there's very little amount of jobs that relates to physics. So I thought, I could become a quant, I could become a software engineer, I could become maybe a consultant, and I could become a data scientist. And it's not really that it was. I mean, I guess it was the thing I preferred, but it's mostly because I got my first job into a data. I mean, my first job was in data science. I mean, the first company that took me as an employee was for a data science position. So I ended up to become a data scientist, mostly because fate chose for me more than I chose for myself, So, and I ended up to like it, and I was very glad that fate chose that well. But I didn't
Yeah.
consider that career path very very early on.
Yeah.
I mean, I had some back and forth where at sometimes, in my academic career, in my academic life, I saw that artificial intelligence thing, and I was like, oh, it sounds
Yeah,
fun,
you were
sounds
interested by
interesting.
that, huh? That's why we're going to these neuroscience
Yeah, I mean,
things.
of course, of course, of course, of course. But yeah, it was a bit random for me, I have to say.
Well, it worked out pretty well.
Eh, yeah, I guess. And so now you're building a startup that relates to machine learning.
Mhm.
You're completely into the right field of natural language processing. With the current hype around that domain, it's the right field. Let me give you a story. Uh, when you told me many years ago that you wanted to build that company, and you told me about the business model, and at the time, I thought, okay, not very convinced, not very
Yeah,
convinced.
normal.
and then you were able to build it and hire people, and for me it was a revolution. I mean, it was a revelation in a sense that Etienne was right all that time.
Mm.
He was able to see through what I could not. So I was very impressed by that ability, that vision that I could not really understand at the time.
Yeah, no, thank
So
you. I mean, it was honestly, I think everybody was asleep before ChatGPT, but like it was
yeah,
GPT-3 was so. I mean, and GPT-2 was like, do you realize what's happening? It was very surprising, and honestly, NuMind should have been done before. But I
yeah,
mean, we always regret that, right? It's not really. And so I was writing this book, and I was saying, weirdly enough, there was no NuMind like being created. And so I was like, okay, well, it's not too late. Let's do it. And then I planned. I mean, I thought that people would stay asleep for another 2 years,
yeah,
since they have been for 3 years already. And yeah, 6 months after incorporating, then ChatGPT arrived. Like, whoa! Now people are very awake.
yeah.
I said to
And
everyone, we have no head start in terms of vision. We have no head start anymore. Now we have to go fast.
you were there at the right time. You were ready for it. That's That's
Yeah. But, a lot of people doing. So I guess we kind of choosing things a bit harder to do.
yeah,
And that way we still keep a bit of an edge, from our experience developing things like that. Because of course there's a lot of applications which are not that hard and a lot of value added. a lot of value added. And so
For sure.
a lot
For
of
sure.
companies are on it. Like assistant for companies, creating ChatGPT for companies is something. It's like, I don't know, $1 trillion business.
For sure.
It's massive.
And
A bit of different route.
I was so you're building that company. You're half in the US and half in France, right?
Yeah, actually more than half in France. I'm at the moment I'm alone in the US. We are 8 in total, and so the 7 others are all in Paris,
Nice.
where my co-founder and CTO is. Which is good. I get to get back to Paris reasonably often. And
And I was wondering, so, I think you mostly worked in the US as an employee, and you were able to launch your company in the US, but you are experiencing something that may be new for you, which is growing the company in France. Um, Are you able to see a difference between the way we work in the US, maybe, and the way we work in France? Is there a different philosophy, different culture around that?
I don't know if there's a big difference from what I see. It's kind of the same people, computer people. It's a bit
Okay.
international. It's a bit international. Yeah, not so much actually. Not so much. I mean, the laws are different, of course, all the legal thing, but otherwise the people, I guess French tend to be a bit more careful. And startups is also special, It's like comparing a company. I mean, Wolfram was, you
Big.
have a lot of freedom. You do. It's
Yeah.
800 people, something like that. 800 employees, something like that. But we had a lot of freedom. We're doing a lot of new things at a fast pace, so it felt to be startup-ish.
Yeah.
And then a French startup. It's actually very similar. It reminds me in the early days when I arrived at Wolfram with a small team and a lot of excitation. It's actually really really fun. It's too bad that I'm not in person. It's good that they all are the same place and that I go from time to time. It's true that when I go to France, it's where most IDs. I mean, the rate of ID is pretty high, and not just ID also, and I don't know, put some extension. We do things a little bit faster, I guess. But it's working very well. Although, yeah, my life is here. Otherwise, probably
Yeah.
would go back.
So that was my next question. Like, you're working in the US. Would you see yourself being able to work in France if it was not for the social attachment you may have here?
Yeah, it's a possibility. But on a personal level, I don't like to live where I already lived. I
Yeah.
kind of like. I mean, I think you can relate that.
Mm-hmm.
I don't know. I got the virus when we were probably in our master. That's where we did like a semester abroad or something like that.
Yeah.
I forgot where you went. You went to UK, I think, no?
Yeah, I went to the UK.
I went to Sweden, and I just loved living abroad. It's
So
so
that's the reason.
yeah. I like to live abroad. I don't like.
Mm.
I love to visit back my country, original country, to have holidays. It's really nice, and there's good food, and there's Paris is a beautiful city. But to live, I like to live in. It seems a bit stupid, but it might be the case that I have to go back to France, and might be very happy as well. I don't know.
Okay.
Well, we'll see. We'll see the needs. I mean, it's really the need of the company. If it's, I mean, at Wolfram, I worked remote for a long time. It was working very well. The entire team was remote, so I think can work very well, and it does. It works very well remote. Me being remote. But if it happened not to be the case, then I might have to go back or open an office wherever I am.
Yeah, I don't think I could go back to France.
No?
I don't know. Like, so definitively, I've gained something coming to the US. For me, it was more about the mindset. I think you can do exactly the same thing in the US and in France. It's two very free countries. You can start companies in both countries. Definitely, you can work in both countries, and there's not a lot of differences when it comes to the laws, even. But I feel that when I arrived in the US, I I was given, there was a mindset of freedom. I didn't feel that I could do more things. I felt that people were more open for me to do things, and that gave me more freedom to go beyond what I usually feel comfortable doing. Like it was easier for me to go outside my comfort zone
Yeah.
in the US because there's this mindset of, if you want to try something, just do it.
Yeah.
Just try. And I really enjoy that. I really enjoy this opportunity to try whatever I feel like doing today. And you could do the same in France, but I don't know. There's a lot of people that are going to tell you, don't do that. You don't know how to do it. Don't try that. It's too hard.
I feel the same way. I feel the same way. That's one of the reasons I went to the US. It's a lot of well-meaning person, they will tell you it's not gonna work, but it's like, yeah, but it's changing. It's changing a little bit.
I
At least
noticed.
for the startup ecosystem, it's changing. And now, if you want to say I want to do a startup, people don't roll their eyes anymore.
Yeah.
So that's
I mean,
that's good.
a good example is NuMind, right? If I understand correctly, the HQ of NuMind is in a place where you have tons of startups, and this has been.
Oh yeah,
Can you tell me more about
yeah. It's
this?
Station F.
Yeah,
And you have, I don't know, maybe 2,000 startups
yeah,
in a massive, old, it's not a train station, but almost.
yeah.
It was, I think, a massive marketplace. And yeah, so you have all this energy, and it's something that is a bit of hype in the sense. I mean, a bit of a, people like to work at a startup, and yeah,
And that
this
place is
change.
that place is a. Tell me if I'm wrong, but I believe that place is the biggest aggregation of physical aggregation of startups at the same place in the world. Is it true?
Might be, I don't know. I wouldn't be surprised. I cannot think of any other place like that.
Yeah.
Maybe San Francisco, but it's not one building in a way. Yeah, it gives a good energy. I think that's no, things have been changing, so that's good. Still, the spirit in the US is a little bit, in my bucket. I have buckets that we shouldn't go there, of what's best in the US and what's best in France.
Yeah.
And in what's best in the US, it's a state of mind related
Yeah,
to
for sure.
ownership and doing things and
For sure.
optimism as well.
I think universities or education can help a lot in promoting a more entrepreneurial mindset. I remember meeting a lot of students coming from Stanford. And this is a place where if you come out of Stanford and you don't start your own company, you're a loser. It's such a push for you to create something new, to go beyond just going to work for an employer. That that mindset it's very hard to find something like that. In the university I went in the US, they didn't have that mindset, and they are trying to really change that and to really be the generator of entrepreneurial mindset. And it's I think it's very important that the educational system can push you in taking risk. And definitively, I don't think the French educational system is pushing you to take any risk. At least that was my
That's true.
feeling being there.
Yeah. No, it was at our time especially, and before probably even more. And this also is changing. I think it's more, they inject more project-based type learning, and which of course force you to take risk and not just, learn your lecture and do the exercise 100 times over and then be very good for the exam. So I think, yeah, this is changing as well. But I mean, yeah, I was not a fan of the. I mean, I think French educational system destroyed some people.
Yeah, it did for me, I think.
That's but you were probably rebel enough to not be completely destroyed
I don't know.
and think by yourself.
I was
And
lucky.
that's funny. We're talking a lot about that with my wife lately because we have kids and so where they should. And it's tricky. They all have pros and cons. Like in France, we learn more stuff.
Yeah, for a longer period of time.
And longer period of times, you know, like in history, in geography, and so on. We have all these facts that the US, if we compare to that, will not have. But it's true. It's not so much pushed toward independent thinking, toward being creative, being innovative. It's not really the thing that is pushing for. And it's
taking risk.
Taking risk, yeah. Like in France, mistakes is of course problem. Like nobody wants to do. Like it's badly seen. Trying something and failing, it's badly seen.
Yeah.
And the way you can see that the worst is more clearly is in learning a new language, learning English, because learning language is about doing a lot of mistakes. It's throwing yourself out there and speaking.
And French people are very bad at speaking English.
Yes, and it's because I think they are scared. There's many people who say, "Oh, you know how to speak whatever Spanish, German, like and they were like, "No, I don't want to say anything because I might do a mistake and everybody might laugh at me." And it's really ingrained, and that's why the French are bad at learning. Also, the fact that we learn the theoretical way, like we learn all the grammar and not speak that much.
It's true. It's true for everything. We learned a lot of theories.
Yeah.
But we don't have a framework to apply that theory in practice.
Yeah, definitely.
Not as much as in the US, at least.
Yeah, it's very formal in a sense. Theory driven, definitely theory driven for many things. Of course, math, prime example. And that's. But I was discussing with someone that was saying, but the great thing is when you have someone that is extremely intuitive and extremely smart, and then learn in this very theory driven and big formalism in France, and they end up middle fields, and that's why we have so many middle fields in math. It's amazing. I think we like think French and Russia, I think, is not so bad, like compared to the amount of people. But I think with the amount of people we are like maybe I don't know. I think we are the best. But it requires a bit of it requires what you have at home. I think it's important. The education that you have at home and your parents and so on. And if you don't have this and you just try to have the good mark in France and you all optimize everything in your brain to get the good mark, I think you end up with some deficit in creativity, in independent thinking, in this. And I've seen that at university. Some people whose brain was good in a way, in a sense they were, they can memorize a lot of stuff. They could do complex reasoning when you put in like the hardware is there. And the way they was thinking, like even in master, when I think about physics and things like that, it was like, you think in pattern matching, you try to reproduce, you try to you try to have your way to do an exercise 100 times over to be able to master the exam. And you actually don't understand. It's not a better way to really understand what you're doing and then go further. And I thought that was pretty sad, actually. And that's the education system that I think maybe it's a personality as well, but that instill that in them, I think.
There might be part of it, might be the way we view politics. France has a stronger socialist culture, socialist democrat culture than in the US, and this implies, this means that people are expecting a bit more from the government, and so what that means, in my opinion, people tend to delegate responsibilities to another entity like the government, much more than in the US. I think in the US, people tend to be more independent. They want to take their independence.
Don't trust the system. Don't trust the government.
much more from the government. And so people in France tend to rely a lot on the government and on social safety nets that are available in that country. So in France, you can live happy because you're not going to, even if you lose your job, you have some safety nets that's going to help you. The education is free, I mean, paid through the taxes, but as a person, you feel it as much. When in the US, I felt that I had to survive. In France, you live. In the US, you survive.
Yeah.
So it's a constant fight. You always need to fight to make sure you don't fall. And as, I don't know, as dark as it may seem, that's a great motivation to get you to go beyond what you seem to go beyond what you think you can do.
Yeah.
When you feel that you can die, when you feel that you can lose, well, you're going to fight further than you actually expected.
That is for sure. which doesn't mean that we should let people die.
For sure.
But yeah, I think there's some system where you can. I don't know. Yeah, but it's true. It's completely true. I feel a bit the same way when I went to the US.
Yeah. Anyway, so Etienne, we are at the 1 hour and 45 minutes mark. How do you feel about stopping here?
All right. Yeah, my actually oldest girl is gonna go back from school soon, so that's the right time.
Sounds great. Okay. Well, in that case, let's part ways today. Thank you, Etienne, for having this conversation with me. It was fun souvenirs, fun memories to have with you, and it was great to learn a bit more about things I actually didn't know about you. So yeah, thank you for coming.
Yeah, thank you, Damien. It was great. Honestly, I had a lot of fun chatting. So thank you.